Good morning, everyone. In this video will be a final presentation of our senior project with the topic of fault diagnosis of centrifugal pump using audio analysis. In this slide will be all of the contents in this presentation. Well, let's start with the introduction. Centrifugal pumps are quality components in most industrial activities. At times, production efficiency depends on how well your centrifugal pumps are functioning. Frequent serving and checkup are ideal for good functioning. However, centrifugal pumps can indicate when they have broken down or are not in good use. It is good to take quick action in case where the pump starts showing the need for repair. Fixing the pump reduces the risk of total breakdown during the work process of the pump having damage beyond repair. Unusual noise or vibration in centrifugal pump are one of the most common signs that often occur when the pump fails. There are several failures that noise can be warning signs, such as cavitation, impeller fault, bedding fault. However, noise can be recorded and it's possible to use it for further analysis to find the cause of pump failure. So, the approach of our project is to use the audio analysis to classify and analyze the types of centrifugal pump failure. In this slide will be the objective of our project. First, adapting IoT problem to the digital signal processing. Next, obtain the behavior of signal in each case and classify signal of each case by the features. Let's move on to the next point. Now let's talk about the classification. Throughout the experiment, we have used 5 centrifugal pumps. Centrifugal pump used in this experiment is Emilo PM45, which all 5 pumps have 2,850 rounds per minute. In our study, we divided the case of pump failure into 3 main categories as follows. First, we recorded the audio data of pump in the normal condition, and we use it as a standard. And next one is the abnormality fault. We use hydrochloric acid from toilet cleaner, which contain of 15% weight per weight of hydrochloric acid into the pump system. The experiment has separately by concentrating of hydrochloric acid, starting from 5%, 10%, and 15% of hydrochloric acid respectively, and recorded 3 sessions per each. Next, for the leaf test, has separated into 3 sets of the experiment by constantly inserting 1 gram per cubic meter of leaf in each set of the experiment. As well as soil, we inserting 10 gram per cubic meter per set of the experiment. And the last one, for the impeller fault, we attempted to insert the gravel into the pump system to damage the impeller of pump and see the result afterwards. There were three sizes of gravel that we used as a sample, as shown in this figure. Let's move on to our experiment setup. Our experiment setup is a closed-loop water system, as shown in this figure. There were 2 sensors used in this experiment, which are microphone sensor and vibration piezoelectric sensor. For the sensor setup, We arranged a microphone at 5 centimeters far from pump. The microphone that used to classify the fault is Fantech Leviosa MCX01, a condenser microphone with a cardioid polar pattern. Frequency response of microphone is 20 Hz to 20 kHz, and microphone sensitivity is minus 44 decibel, plus minus 3 decibel. The USB audio used is USB-A to USB-B, directly connect into laptop with sample rate of 48 kHz at 16 bits. For the piezoelectric sensor, this sensor can directly connect with Arduino or ESP32 Raspberry Pi to receive a data. We stick it a piezoelectric sensor with the pump, but finally, we will mainly use a microphone sensor to obtain a result for further analysis due to the piezoelectric sensor was lack of accuracy and difficult to estimate the obtained value.
Next, feature extraction. Feature extraction is an important part of signal processing, which is significant for signal detection, classification, and recognition. There are many features extraction techniques and analysis, mainly time domain, frequency domain, and power spectrum. In time domain analysis, there are features that mainly use such as mean, RMS, and kurtosis. And in power spectrum, mainly use mean frequency and mean power gain. We will go through our studies feature first with RMS or root mean square in the time domain analysis. In time domain analysis, the difference of amplitude is shown in y-axis and difference of time in x-axis. The square root, the RMS is the square root of mean square of the equation shown in the slide. RMS is one of the most important parameters that signifies the size of a signal or strength of the signal, which is proportional to the amplitude. The advantage of RMS is its tolerance to signals that have both positive and negative value from negating each other by normal mean approach. But the disadvantage is long computation time compared to normal mean approach and only suitable for data with positive and negative value in one array, which doesn't mainly use if need to compare with other data that would prefer normal mean. Next, we will go to the mean power spectrum in power spectrum analysis. In power spectrum analysis, the difference of power gain in dB in decibel is shown in y-axis and difference of frequency in x-axis. The power gain in power spectrum usually displayed in decibel unit, not actual power gain due to its ability to contain larger scale of data due to log property. And the power gain can be converted into decibel unit with the equation of 10 multiplied log power gain. This approach is about finding the mean of power gain in power spectrum using PS spectrum function in MATLAB, then mean function to find mean power gain. However, in order to use power spectrum analysis, there is need to preprocess the signals first by high-pass filter with passband frequency of 0.25 times of Nyquist frequency of 551.25 Hz and 0.95 stiffness to eliminate that unwanted amplitude in low frequency range. The Nyquist frequency is a half of sampling rate of the signal, which are 4,410 Hz in this case. The advantage of mean power gain in power spectrum analysis is a better accuracy compared to others and have lesser chance for overlapping result due to its large containment ability of logarithm. However, the disadvantage are the requirement to preprocessing the signal first with high-pass filter and required to fast Fourier transform the signal to utilizing the features which took longer computation time for the whole process. For the result part, starting with time domain analysis, the figure showed that the signals are different from each other between the normal case and other case in time domain. The figures show the RMS value with range of positive minus 5% error of each case, which there are some overlapping value between each case that prevent classification, which will be look more into the detail in a table. The table 1 shows the result of average RMS value for time domain signal with positive minus 5% error. The same highlight color value in the table indicate the case that have overlapping value with each other, with case 1 overlap with case 7, case 3 with case 9 and 10, and case 4 with case 5. So there are need to adopt other approach as well of features extraction. Next is power spectrum analysis. The figure shows that there are subtype chains between the normal case and other case in power spectrum. The figure shows the mean power spectrum with range of positive minus 5% error of each case, which show that there are also have overlapping value as well, which will look more in detail in the table. The table 2 shows the result of average mean power gain value for power spectrum with positive minus 5% error range. The same highlight color value in the table indicate the case that have overlapping value with each other, with case 1 overlap with case 4 and case 5 overlap with case 7. After finish the feature extraction, next is to combine the result to fully eliminate the overlapping value of each case. The combined result, the table 3 shows the combined result of average RMS and power gain lower and upper limit, which will be observed the overlapping value in the next slide. The figures show the interval of positive minus 5% error, both average RMS and mean power spectrum. Using the power spectrum analysis as a base analysis, there is need to eliminate the overlapping value in case 1 with case 4 and case 5 with case 7 by average RMS result. The RMS result of case 1 and case 4 are differ from each other largely, with value of 0.03268 to 0.03612 and 0.06498 to 0.07812, same as the result of case 5 and 7, which are differ from each other largely as well in RMS value, with the value of 0.069065 to 0.076335 and 0.033725 to 7.03775, which indicate that we can fully classify each case with the distinct and without overlapping values.
In this part, we'll show the pump condition after it has been disassembled to view the changing condition by comparing with the normal condition of the pump by mainly visualized from the pump impeller. Starting from the right figure is the pump condition after hydrochloric acid test. It appears that there was corrosion through the impeller during the experiment. And next one, for the leaf test, in the left figure, it shows that the leaf did not pass through the impeller. In this case, the impeller may not be affected. And the next one, the soil had entered the impeller and interfered with the impeller operation. However, after the impeller has been cleaned in the right figure, it appears that the impeller is still not damaged. And the last one, after the gravel has inserted into the system, the gravel has got stuck in the impeller and spin together only 1 minute. Then the pump was stopped to work immediately. From the figure, it appears that the gravel have rapidly destroyed the impeller. In this part, we'll show the result from vibration piezoelectric sensor. The result from this sensor was unreliable. It was difficult to classify the type of pump failure. So we didn't decide to use it as a main sensor. In conclusion, in this study, the audio and vibration signal have been studied for feature detection in time domain and power spectrum analysis. The study is mainly concentrated in audio signal and discard vibration signal due to its incompetence and unreliable after feature detection. In audio analysis, the features are separated into two analyses, time domain using RMS and power spectrum analysis using high-pass filter and mean power gain. From the result, it indicates that the study is successful with the uniqueness of combined result in each case. They prove that RMS and high-pass filter, in addition with mean power gain, are features that can be used for distinguishment. The validation and predictive analysis can be studied further from this study, even embedded prototype. From the result of vibration signal indicated inefficiency in classification due to many constraints, such as price of the proper accelerometer, which limit the choice of vibration sensor. The aforementioned problem can be solved with more budget for proper accelerometer. Thank you for your attention.